All right, Nick DeTiro here. Let me address some issues, overall issues about the curriculum. You will notice that in all of our ITCS curriculum throughout the entire department, we have a programming logic course in there. And I've heard this from students many, many years, especially in the networking and now in cybersecurity. I'm not planning to be a programmer. Why do I need, at a minimal, why do I need the programming logic course? And then for the cybersecurity, we want you to take Python. And the answer to that is easy. Well, easy for me to understand. When we develop these courses, we try to be as comprehensive as possible, but more importantly, we understand that there are tools you need to bring into the workforce. And one of the biggest tools you can bring into the workforce is problem solving. And fundamentally, programming logic is one of the best methods for problem solving. So that's an easy explanation. But now more and more of our IT curriculum, IT computer science curriculum, does require students to understand and actually program. In ethical hacking and networking, there is a lot of automation. And automation is the process of taking tedious tasks that could be, may take you 4, 5, 6 hours, even days, where maybe investing a little bit of time writing a little bit of code instead of taking 4, 5, 6 hours or 2, 3 days of doing something, you can write some code and maybe it can be accomplished literally in an hour. Also, there are times where you may use that code in the future. And in ethical hacking, we do a lot of automation. There's a lot of libraries associated with ethical hacking tools. So it's important that we cover programming logic, and that's why we also chose Python. Now, before we get started, we're going to spend this video really talking more about automation. This is probably, I consider this probably one of the better books out there on the market for automation. It's not a required textbook for this course, but if you're interested in programming for automation, it's an outstanding book. Actually, any of the No Starch Press books I've been very impressed with. They're very easy to read. Some get into some really interesting concepts and stuff like that. But I also have another book here. I know I don't use this book too much. This is also from No Starch Press. I'm not going to personally recommend it. It's not a bad book. It's Black Hat Python. Basically, they teach you some coding to do some things in ethical hacking, specifically using Python. Let me go up my screen real quickly. And up on my screen here is what looks like a cute little robot connecting with red strings and stuff like that. No, this is a great example of what they call a botnet. A typical hacker, I'm sorry, a bad actor is not going to launch their attacks from their machines. One of the biggest things that hackers will do is they try to go out and find machines that they can compromise, not to acquire the information off those machines. That would be nice, but to use those machines as launching off points. Those are referred to as those botnets you'll often hear inside news reports and stuff like that. And sometimes you'll hear these really large numbers. You'll hear such and such an attacker launched denial of service attack or distributed denial of service attack from 300,000 bots or 300,000 of these computers. And you get in your mind, how did one person was able to compromise over 300,000 machines? Well, they're not sitting in their basement compromising one machine at a time. They develop code, and they develop code through automation where the code will actually go out and look for vulnerable systems. And then they write the code for the malware code that actually then can launch seek and destroy, or actually seek and find missions. So I want to point to kind of a famous bot attack, and it's called Mira. And Mira came out in probably around 2016, 2015. And what's interesting about this one is it's still out there. It attacks IoT devices. It originally, if I remember correctly, it originally attacked some IP cameras, some digital cameras. And what they did, the developers did, fascinating, was they learned that there were certain cameras and other IoT devices that were still running based upon their default credentials. When a IoT device or a lot of devices leave the factory, they have default credentials in them, a username and a password. And you want, when you get those devices, you want to change those. A lot of people just kind of hang those on the wall, hang the device on the wall, and they forget or they don't think about changing the default credentials. And what Mira did was it basically was able, if it could compromise one device, and again, this was hacking digital cameras, but you've heard me talk about this several times. Anything that is smart, any IoT device in there, there's a good chance that device is running some flavor of Linux to it. That allows it to use Wi-Fi features, Linux commands. Now, these are very stripped down versions of Linux, but there are Linux. So the little light switch I have in my wall, I have about 20 of them. I know they're running Linux here. They come out of factory to default, and what Mira did was basically it was able to compromise at least one device. Once it compromised that one device, it had the intelligence where it went out to as many devices as it can find. And if it found those devices with default passwords, see, default credentials are available up on the internet. Manufacturers will often or do release information about default credentials. And the only way around Mira initially was to reset those devices and then immediately change the default username and password. Mira was so intelligent that even if you reset the machine, you reset one of those bots, within, I want to say a couple minutes, sometimes I hear 100 seconds or something, it would get infected again. So this was a really interesting attack. So think about all the billion and billion of IoT devices out there. And this was in 2016 when this initially, it's still out there. If I call it she, I'm not being offensive, but Mira is also, I believe it's an anime character. And one of the things I thought was interesting when I was researching this topic was Mira constantly scanned the internet, and that's fine. That's what they're meant to do. But it also included a table, I love this, included a table of ranges that will not infect, including private networks and addresses associated with the Postal Service, U.S. Postal, and the Department of Defense. Remember what we've talked about in previous classes. These bad actors are often very cautious about who they attack. And obviously, they didn't want the full force of the Department of Defense, the U.S. Postal Service, things like that to come down on them. So they created this botnet, the software that created this botnet that wouldn't attack the Postal Service and wouldn't attack the Department of Defense. All right, let's take a look at some rudimentary automation. All right, this is not a programming logic course. This is not a Python course. So we can't really spend a lot of time about the specifics of Python and programming logic. The two assignments are fairly straightforward. Most people can accomplish them in a couple hours. But I want to show you the process, the procedures, the methodology associated with developing these automated tools. And actually, we have already been using some of these automated tools. Right now, I'm at my screen. I'm just up at the python.org location. They provide a wealth of information. But do you remember our old friend HPing3 from a couple labs ago? Well, HPing3 is written in Python. So that utility that we used in a couple labs, the one that we were able to simulate denial of service attacks, that is a Python script. So we can see where this can generally take us. A lot of times these scripts that we'll see in Kali have been written in some kind of programming language like a Python or something like that. But where do we start? We start with a problem. And again, if you were to take programming logic, you take Java, Python, or you always start with a problem. And I'm going to start with this problem here. Now, this problem is not an ethical hacking problem. This is a forensics problem. But again, this discussion is not about programming, ethical hacking programming, but about automation and scripting and things like that. And I already have code generated for this particular problem. This problem basically says that I have a USB drive. And somewhere on that USB drive are two files. One has an MD5 hash value of this, and another has a SHA-1 hash value of this. Now, where do I start with the programming? I start by searching the fine web. Well, I don't even start there. I say, well, you know what? I'm not going to write script. I'm just going to hammer through this assignment. There's a USB drive, and I got to calculate the hash values for all the files on that USB drive. So I'm going to take a look at that USB drive, and that's this one right here. And I'm just going to start. Okay, there appears to be a bunch of files there. All right, I'm still going to hash. So I'm going to get my hash calculator, and I'm going to say, okay, tell me the value of that USB drive, this very first file. Calculate, give it a second. And then I start comparing this with the known value. Nope, that's not it. So I'll go to the second file. Again, I'm being facetious here. This would be absolutely ridiculous. I don't know how many files are in that USB drive. If it's one file, two files, absolutely. You'd save time by just going to the calculator. But there could be 10 files on there. There could be 10,000 files on there. I don't want to be doing this hash calculator and comparing that to any hash values that I'm looking for. So now it's time to think about scripting. So I'm going to close that. And I say, okay, there's a couple things I need to be aware of. I'll write it in Python. That's one thing. And I know Python has a lot of libraries as it's used. What would be some of the libraries that I'd want to use? Well, since I'm searching a USB drive, I might want some kind of library associated with scanning through a directory or looking at things in a directory. Since I'm going to be calculating hash values, MD5 and SHA-1, maybe something else later on, I'm going to look for any particular library that has a Python library that would allow me to send a file there and let it generate a hash value. And then I might want to store it. I want to keep this information. This might be a really useful tool down the road that maybe I want to keep it, the output, in a standard format. And one of the standard formats that we use is comma separated values. Very, very standard. So maybe Python has those particular libraries. Now you're saying, Nick, you already wrote this code. You know what libraries you went to. Absolutely. But again, suspend disbelief for a second here. This is exactly the process that I went through. And actually, I looked through a whole bunch of libraries to get to those threes. I still felt it was easier than trying to do the hash calculator on this particular situation. So let me go to those particular libraries. Here is the library OS. It allows us to run miscellaneous operating system interfaces. That might be a pretty good start. And then I would scroll around, and what I'm looking for, you already saw it, I removed it. I would read, and to save time, I'm not reading. I found this command here, this os.walk command, and what it did was it generated the file names into a directory tree. Oh, that's kind of good. And it's a tree. Either we know the directory is set by a tree for each directory in the tree root at the top. So basically, I can start at the top of the directory, And what it's going to do now, this tuple has to deal with Python specifically. It's going to go down whatever hard drive I tell it to go down to. I'm going to go to a USB drive, and it's going to take all that information and it's going to put the directory path, the directory name, and the actual file name for every single file that I call for. And since I'm calling for the top of the root, this is probably a command, a function that I want to be well aware of. What about HashLab? I did a network search and I found out there was a library called HashLab. It basically secure hashes. You send it the link or you send it the path to a file, and it's going to hash that file. And look, they have functions for MD5, SHA-1, SHA-256. That, again, this is what I did in this process. And this is when you start programming, you look what's out there on the internet and see what libraries are associated with it. And then finally, there's the CSV reader and writing, which basically means somebody created a whole bunch of libraries that allow me to read a CSV file. Well, we're not necessarily reading a CSV file. We can do that later on, but I want to write a CSV file so I can use the data that is output later on. I will tell you something. I use this particular library all the time. When I'm working with Python and I'm doing some scripting and stuff like that, I tend to try to write my stuff into a CSV file, and then vice versa. I try to draw information because I know the specific format that I'm creating with the CSV file. So I've done some library research. Other libraries that you may be of interest, I've talked about now, maybe not for this program, but for other programs. There's this beautiful soup library. It says it's a Python library for pulling data out of an HTML and XML files. What a wonderful library, especially if you're doing any kind of scraping or investigation of websites. This will actually pull that information and format it very, very well. Here's another Python library. This is a library that I can do all those nmap commands that we saw in previous classes, that, Swiss Army knife of ethical hacking, nmap. Somebody actually wrote a library that uses all those nmap commands. So instead of running them from a command prompt, I will be doing them through Python. So we have a problem. We did some research on a problem, and now it's time to code that problem. Now, don't get overwhelmed by the code that I'm going to show you. This code, if you're curious, I'm in the IDE PyCharm. Watch the other videos about different IDEs. I use PyCharm because it's something I've grown accustomed to. Is it the best IDE out there? No, but for me, it works fantastically. But I created this automated program that basically will scan the USB drive, and I'll walk through there, and it hashes every single file in that USB drive, starting at the top of the drive and navigating down and going through the entire file directory tree. And every single file, it goes out and gets the hash values associated with that particular file. Here is my importing of those files I was talking about. OS is going to allow me to use any that tree walking, but allow me to use any of the OS commands. HashLab will allow me to both read and write to a CSV file, comma separated values. Since I'm not going to be reading, that's fine. I'm going to do writing, and away we go. I know I'm scrolling by very, very fast. This is not a Python course. This is not a programming logic course. This is just kind of explaining the methodology that I went through. So if this code looks foreign to you, I understand it. Don't worry about it. Again, it's about the methodology. The first item to be aware of is that I created an output file. So I'm going to create an output output file called a_file, and I'm going to open up a file called filehashes.csv. I am going to write everything as this is scanning. I'm sorry, as the program is scanning, it's going to write this to a file called CSV. And that's what these particular lines will do. The very first row, the top row of that file, and we'll look at that file in a bit, you'll see the columns of file, MD5, SHA-1, and SHA-256. Then this for statement, this definite loop, it's looping through the USB drive. So it's not looping through a list. It's not looping through a dictionary, a tuple, a file. It's actually looping through the USB file. So it's going to hit every single file in there. Now, it's a definite loop because it's fairly easy to determine how many files would be on that USB, right? So it's easier for Python to figure it out. It doesn't have to wait to the end of a file or anything. It says, you know what, we can take care of that. And then don't worry so much about this logic. This logic is basically this particular logic right here is building a full path to each individual file. This prints it. More importantly for us is these function calls. I created 3 functions. One function will generate the MD5 hash for the file. One will generate the SHA-1 hash, and one will generate the SHA-256 hash. Now, if I scroll back up here, here are the functions. Now, if you're familiar with Python and you're a Pythonista, which is a legitimate term, my code probably isn't that attractive to you. It's a hack job. It's something I threw together in about 45 minutes. It took me about 45 minutes from the point of I need to do research in the libraries. Okay, I discovered the libraries to actually writing the code and testing the code. Yes, I have some familiarity with Python, but this is not the most elegant program in the world. So if you see something in here and you're a Pythonista and you go, I could have done that better, or my logic, absolutely. Every single programmer is going to have their own style. My particular style here was to create 3 functions. One function would find the hash value for MD5. One would find the hash value for SHA-1, and one would find the hash value for SHA-256. Yes, there are some people who are looking at this going, this breaks all the rules, Nick. You're duplicating code. It's the same. I get that. I really, really do. And yes, I could write this program much better, but you know what? 45 minutes of work and it does the job fine. It saved me 4 or 5 hours of going through 60, 70, 80 files through the hash calculator. So I wrote the code. Now it's time to run it. Now, I wrote the code from the moment that I wanted to write the code to finishing the code took me about 45 minutes. That included the library investigations. That include writing the code. I had a little working knowledge with Python. I will be honest with that, but it really didn't take that long. Once you become familiar with this stuff, once you become familiar with looking at a problem and then trying to determine how to solve that problem with some kind of code. So let's run this program. And right now, you can see down here, it is going through, it is iterating through every single file on that USB drive. It takes the information, what do you call it? The directory path of that file, sends it up to 3 different hashes, calculates those 3 different hashes for every single file, and then writes it to a CSV file. So give it another minute. All right, it's done. Let's take a look at the CSV file. This is colored for a reason. But if you look at this, the very first line, and this is important for the CSV function, the very first line says the file name. It's MD5 is always going to be in red, so the file name is going to be in this orange. MD5 hashes will be in red. SHA-1 hashes will be in purple, and SHA-256 hashes will be in that I guess, green. It's kind of an ugly green here. Well, let's go back to our problem. And our problem says, find the files of a value with the following. So I'm just going to do a quick copy and paste here. I'm going to copy this and I'm going to go back to here and I'm going to say, find me. That's what's going on up here. Find me that hash value. And now that's interesting. That is really, really interesting. It's an MD5 file, MD5 hash. There's actually 2 hashes that are using that. And I also noticed that why would the SHA-256, there's something wrong with my logic. All right, there's something. Why would no, that's not right. That's not right. So let's go through the walkthrough and let me look at my SHA-256. Oh, of course. There's an error in my SHA-256. So let me change that. I hate when I don't know where my cursor is. 6. All right. Let's run this code again. All right. Let's see what the file hashes come up this time. Okay, it's still finding. Now my my SHA-256 problem has been resolved, but this is not a programming problem. This is actually 2 files that have the same MD5 associated with them. Actually, if I look at these 2 files, all of their hash values are identical, which tells me what? It tells me that they're actually the same file. They're copies of the same file, but somebody decided to rename them, try to obfuscate their original intent, right? So this is kind of suspicious, but my program worked. My program said it found this file, 2 files with the exact same hash. The names were different. What about this other one? How about this other one? Let's try to find that file. And there's one file out there. There's one file with is it SHA-1? Yeah, SHA-1 hash here, and it goes to this particular JPEG. Not so much trying to impress you with my automated skills and my time-saving skills and stuff like that. But this program really was more about demonstrating automation than it really was trying to find hash values. But you can see how many on this USB drive, there were 79 files. If I try to go back and do the exact same thing manually, it would take hours. I mean, 3-4 hours. And I did tell the story when I reached out to the professor. I said, you really want us to hash every one of those files? And he said, yeah, that's how it's done. And then I said, no, I'm good. I didn't tell him this. I did it this way. I found what he was looking for. That's what I submitted. Now, what was the sidebar to that? When I told him about my situation that I wrote code and this was really interesting, he said, oh, that's nice. And he went around his own little way in that. So not about really the hashing, but the process, the methodology associated with this automation. Let me read from the textbook. One of the textbooks that I have here, I mentioned this Black Hat Python. Not one of my favorite books. It's an okay book, but these are the chapters. Chapter 3, the network raw, sockets, and sniffing. Chapter 4, owning the network with Scapy. We did see Scapy in one of our labs. Chapter 5, web hackery. Chapter 6, extending burp proxy. We will talk about burp proxy in this course. Chapter 7, GitHub commands and control. Chapter 8, common Trojaning task on Windows. Chapter 9, fun with Internet Explorer. Chapter 10, Windows privilege escalation, and Chapter 11, automating offensive forensics. So we do see the power of automation. We see the power of Python doing this stuff for you. We talked about botnets, the automation process, and things like that. So even though this course is not a programming course, hopefully we see the importance of programming and understanding programming logic and things like that for pretty much all our courses. Now, let's go out and use something.